Alright, this is a quick video on how to solve equations, quadratic equations, by square rooting both sides. Here's a very simple quadratic. We've got x squared equals 4. The key to using this method is you don't have a linear term. Remember, standard form is ax squared plus bx plus c equals 0. So if the linear term is missing, all you've got is a term that has an x squared in it and some constant. Okay? So here you can see I've got an x squared term and some constant, so this method works great for this problem. And we just undo the squaring by square rooting both sides. Now when you do this, though, you always get plus or minus and then the square root of whatever your constant is. In this case, the square root of 4 is 2. And what this means is x is either 2 or x is negative 2. We just usually write this abbreviated form, which means the same thing. The reason you have to have the plus or minus is because both make it true. If I square a 2, I get 4, and if I square a negative 2, I get 4. Okay? The next examples are a little more complicated, but not much. In this example, I've got just a quadratic term and a constant. I want to isolate the quadratic term, and now I can square root both sides. X equals plus or minus 3. Again, that means plus 3 or minus 3. This one's even a little more complicated. I take the constant to the other side. X squared is not alone yet, so I divide by 2, and now I square root both sides. Notice I can't take the square root of 3, so I just leave it as plus or minus whatever root 3 is equal to. It's some decimal value. That just means x is either equal to the square root of 3 or x is equal to the opposite, the negative of the square root of 3. And then finally, our last example, quite a bit more complicated. But the key thing is, over here is a perfect square, and it's got the x inside of it. I don't care what the right side is. What I care about is there's only one x. There is only one x. It's inside of a perfect square. And what we mean by a perfect square is I can square root it, and I just end up with x plus 4. Notice the square root undoes the squared function. Over here I still get plus or minus, and I get 5 because the square root of 25 is 5. Now to solve for x, I have to subtract 4 from both sides. Now we could stop here, but these are nice integers, and so it means x is negative 4 plus 5, or x is negative 4 minus 5. And I can simplify both those to find out exactly what x is. X is either 1 or x is negative 9. Again, this only works when square rooting it. Get you an x by itself that is just linear, x to the first power. There are some other ways to use this method, but this is the primary way we'll use it in class.